Hi everybody, this is Bharat, Assistant Professor, Department of EEE, SNS College of Technology. We are seeing in the lecture series video for the course Fundamentals of Measurements and Instrumentation. In that Fundamentals of Measurement, we have been seeing different topics. Today our topic is going to be about types and sources of errors in measurement. Come, let's get into the video. Let's just recall what are the previous topics, what we have discussed in this lecture series. We have just discussed about the various fundamental elements of an electrical instrument, the characteristics such as static and dynamic characteristics of instruments, and what are the various types of instruments, electrical instruments, statistical treatment, what we have seen. And today we are going to discuss about the various classifications of types of errors. To understand these concepts, we have just discussed about the functional elements, what are the various types of systems, like direct, indirect, active and passive, null and deflection, analog and digital, and static and dynamic characteristics of instruments. In today, we are going to discuss about what are errors. As we all know, error is nothing but what is the value to what we just find out or what we just get from some data. The difference between that exact data and the measured quantity is called as the error. What we need and what we got, the difference between that is called as the error. Or what actual value to the value what is measured, the difference is called as the error. Any value without an error measurement is very, very critical. So as per the definition, error is the difference between the measured value and the true value. Error is defined as the measured value minus true value. What are the different types of errors? Errors are classified into three different categories. One is called gross error. Second one is called systematic error. Third one is called random error. Gross error. Gross error is done by human mistakes, reading or recording errors, etc. Systematic errors is consistent deviation, predictable in patterns, etc. Random errors are irregular fluctuations, unpredictable variations, etc. Why understanding errors is a very important matter. Errors affect measurement accuracy. 100% accurate measurement is impossible. Understanding errors is crucial for reliability. What are the different types of errors? The first what we have seen is the gross errors and systematic errors. Gross errors. The errors which is made by a human during the measurement operation. For example, a human just see over the sight. He may mismatch for 5.1 to 5.2 and get a different value. The reading may be taken wrong, as 23 can be taken as 28 or 28 can be taken as 23, a small error which a human eye can occur. Recording it incorrectly, calculation mistakes, all these comes under the category of gross errors. How to reduce these gross errors? It can be reduced by carefully observing multiple experiments and cross-check the measurements. Systematic errors. Systematic errors are classified into instrumental, environmental, and observational. Instrumental errors are faulty constraints, calibration errors, hysteresis, and zero error. Environmental involves the temperature effects, outside atmosphere, pressure variations, humidity changes, and magnetic field changes. Observation error, what we see in the site, parallax error, personal bias, carelessness, and improper setting. The key characteristics is the systematic errors have consistent magnitude and sign, resulting in the bias of measured values from the true value. Random errors is irregular. They cannot be classified under any of these categories. Irregular and unpredictable fluctuations in measurement is called as a random error. The common one are unpredictable temperature failures, voltage supply variations, mechanical vibrations, observer reading variations, etc. This could be calculated using very important three terms what would have studied in your maths also, that is mean, median, standard deviation, and normal distribution. The characteristics involved, they occur randomly, vary in magnitude and sign, cannot be eliminated, reduced by averaging. What are the sources of all these errors? Instrument errors are due to non-linearity, hysteresis, that is the BH curve what we have studied, zero error, loading effect, and limited resolution. Environmental errors includes temperature changes, deformation, magnetic for electric fields, humidity, etc. Operation errors involve technique variation and recording errors, transposing number, different procedures, and reading inconsistencies all comes under the operator error. Fixturing errors, poor connection, improper fastening, loose clamps, support placement, and alignment issues. Error distribution, measurement error sources, systematic error involves. Errors calculation. How do we calculate the error? Absolute error is calculated by measured value minus the true value. Percentage error, absolute value divided by true value. Relative error, absolute value or absolute error divided by true value. Accuracy is a closeness to the true value. Precision is the consistency of repeated measurements towards that value. Statistical methods like mean, median, standard deviation, average spread, or normal distribution like bell curve all comes under used to calculate these accuracy and precision targets. How to reduce these errors? Error reduction strategy is given as I did part. Identify error source first. Apply appropriate technique to reduce the error. Verify the effectiveness regularly. Suitable calibrations, high precision instruments, multiple measurements, controlled environment, cross-checking, and having some proper procedures involves to reduce these errors. Reduction strategy must be systematic and continuous for reliable measurements. So on summarized part, we have just discussed about the various errors in measurement like systematic errors, random errors, and gross errors. Thank you. We'll meet in the next video soon.